Hello class, this is a video tutorial on the cubic function part 1. In this video we'll be looking at the general shape and some basic properties of the cubic function. So a cubic function is a function whose highest power of x is 3. So take note that x there has the highest power of 3. Its domain and range are all real x and y, and its general shape is shown below here. So if there's a positive coefficient of x cubed, the shape will look like this. This shape here is, well, if you take note of it, it's always increasing even though it's slowing down here. So it's increasing, it slows down the rate of increase and then increases again. Whereas in this one, with a negative coefficient of x cubed, it is always decreasing. Okay. The constant value of d here shifts the graph vertically and also determines the y-intercept. So before, our graph was here, like this, and that was x cubed, but because we added some constant, it shifted the entire graph upward. Okay, which means that the y-intercept here is going to be at 0, d. Likewise, if we have the function here, which was originally like this, we subtracted a constant of d, so it shifted downward the y-intercept to 0, negative d. By letting f of x equal 0, the root of f of x will be cube root of d and 0. So I'll demonstrate to you here. Take a look at this one. If we take this expression, if we let f of x equal 0, we get x cubed plus d equals 0. X cubed equals negative d. X is equal to negative d, but the cubed root of it. Okay? And the same will follow if we apply it to this one as well. Okay? Now, here's a particular point that we need to learn. It's known as the point of inflection. Similar to parabolas, quadratic functions, a cubic has concavity, but cubics have two concavities. Between the two concavities is a point where it changes between concave up to concave down, or vice versa. I'll demonstrate to you what this means. Take a look. If you take a look at this first section, you can kind of see that it's going to cup downward like this. And this next part is cupping upwards. So let's do this two different colors. So this one here is cupping downwards, kind of like that. And this one here is cupping upwards, so it's concave up and concave down. But notice how there's a point there in purple where it changes from concave down to concave up. It's more obvious in this one. I'll demonstrate it again. Here it is, concave up. It's very obvious where it is. Whereas this part here is concave down. But notice that there must exist a point somewhere in between where it's changing from concave up to concave down. In this one, we don't know where it is, but that point is known as the point of inflection. In basic forms of cubics, f of x equals x cubed plus d. The point of inflection will always be the same as the y-intercept. So take a look. So currently the y-intercept is at 0, so the point of inflection is at 0, 0. The y-intercept is at 0, d, so the point of inflection is at 0, 4. Likewise here, the y-intercept is at 0, negative 2, so the point of inflection is there as well. Okay, so let's get to some examples. Calculate the x and y intercepts of the following cubics and sketch the functions. Well, like we've done before in other examples, to find the y-intercept, we let x equal 0. So we go f of 0, that's 0 cubed plus 27, well that's just 27. My y-intercept is at 0, 0, 27. My x-intercept, we let y equals 0. So we take the expression x cubed plus 27 and we let that equal 0 and we solve for x. Using my calculator here because I'm not quite familiar. Negative 27 cube root is equal to negative 3. So graphing these 2 points, let me just move this a little bit closer up. Graphing these 2 points, 0, 27, we'll just scale it here. And x of negative 3, let's just say it's here. It doesn't have to be entirely accurate. Just a quick sketch. So this will look something like and then continuing on like that. That is f of x. Oh, and little arrows in the bottom to indicate there. And let's indicate what these points are. This is negative 3, 0. And this point here is 0, 27. Not to scale. Let's do one more example. Let's find the x and y intercept here. Y-intercept, x equals 0. So f of 0, that's very easy. That's just 8. So my y-intercept is at 0, 8. My x-intercept, we let y is equal to 0. So we take the expression and we let that equal 0 and we solve for x. Taking the cube root of both sides, that will be 2. Okay, so it's at 2. And my y-intercept, oh sorry, it should be at negative 8. Getting a bit confused with the drawing there. So negative 8, let's say it's down here. So the point of inflection is also going to be here, meaning the graph should look somewhat, actually let me move this up a little bit. Should move somewhat like so. And then there we go. Doesn't have to be entirely accurate, but the shape should show a cubic of sorts. Okay, let's do 2 more examples here. Same case, we take the y-intercept. This one's very straightforward. F of 0 is equal to 12. So 0, 12. We take the x-intercept, y is equal to 0. So we let the expression equal 0. Solving for x, we get, moving this to the other side, we get 12 equals x cubed. Taking the cube root of 12, whatever that might be. Let's take an approximation of what that is actually. 12. Oops. 12. Approximately 2.29. oops, sorry, and we forgot something. In this one, I didn't indicate what these values were. This is supposed to be 0, -8, 2, 0. Doing it again here. 0, 12 up here, and approximately 2.29. Let's say it's about here. Now, because we have a negative cubic, it should be decreasing, should be moving down like this. So let's indicate our points. Let's make it pass through our points rather. Okay, we gotta make this scale a little bit better. There we are. Indicating our intercepts. 0, 12, 2.29, 0. One last example here. Y-intercept. We take f of 0 is equal to -9. So our y-intercept is 0, -9. We take the x-intercept now. We let the expression equal 0, and we solve for x. Cube root of 9. About 2.08. Graphing all the critical points here. 0, -9. 2.08. Interesting. It's a decreasing function, so it should be doing this. But -9. Oh, sorry. This one's perplexing me. It should be -9 here. Oh, sorry. There we are. It's a -9, so it should be a -2.09. There we go. I took the +9 for that root. So that solves our problem. There's our root there. Coming through like this. There we go. -2.08, 0, 0, -9. So I hope that gave you an insight into the general shape of cubic functions and how to graph basic versions of them. Hope to see you in the next video. Best of luck.